Okay, on my previous video, uh, I discussed a laboratory that we did in the lab on series and parallel circuits. I can show you the that particular lab. This was it. The Discussed the resistors in series, resistors in parallel. I've updated it since that last video. I've updated the uh, the PDF, um, the series parallel circuits, and then I show you the circuits that we were doing in the lab: the series, a parallel, and then a series parallel, and then an alternate series parallel. I guess you could almost call this parallel series. And then we had a data table for each figure. We had a data table that you would put down the resistances, the indicated resistance from the band, the measured resistance with the meter, the calculated voltage that you would expect in the circuit, the actual measured voltage, the calculated current, and the measured current, and then the percent difference current, and then basically each table was the same, but I had a table for each figure, so that was the lab that we discussed, and I'm going to dismiss this, and we're going to discuss the circuits. Let's see. Uh, since I closed it, we're going to be discussing these circuits and how to create them. And let's not do. Let's do a single page. There we go. So we're going to have a series, a parallel, the two parallel lines with a series embedded in it, and then a series with the second part of the series being made up of a parallel circuit. So we're going to use, let's do a new share, and we're going to use the Phet, from the University of Colorado at Boulder. They have a nice simulator, and so the website is Phet.Colorado.edu. So you can go there, and over here on the simulations, they have a bunch of simulations in physics, chemistry, math, earth science, biology, and we're going to stick with the physics. And once we get the physics up, we're going to just concentrate on the electricity, magnets, and circuits. So if we go there, we're not doing AC, so these don't count. We're going to do the DC construction kit, this one right here. So click on that, and then we'll hit the play button, and we're going to choose the right image and do the lab. And I'm going to dismiss my image here because it interferes with the screen. I want you to see all of these controls over here. So the first thing we're going to do is we're going to do that series circuit where it was just a battery, an ammeter, and 3 resistors in parallel. So I'm going to show you how to, let's start with a battery, and let's put a switch, and let's put a meter. Let's use this ammeter. We'll use the other one later. And then we're going to take 3 resistors. 1, 2, and 3. It may not come out very neatly, but we're going to get the job done. So now we have to connect all of these. So let's take a wire, put it there on the meter, and connect it. And you can see the red circle turns black when the connection is made. So then we need to connect this and connect this. And so it doesn't look too wonky, I'm gonna make this flat and just add another wire here. Okay, and there we have a circuit. Now, wait a minute. They're all 100 ohms. I don't want them all 100 ohms. In the lab that we performed, we chose 1,000, 560, and 330. You don't have that luxury here. The max you can get is 120 ohms. So we're going to set this one to, we're going to scale everything back. There's 100 ohms. We'll make this one 56. We can't get 560 because the max is 120. We're going to do 56 ohms, and then we're going to do this one 33 ohms. If you can't get it, there's 33 ohms. If you can't get it quite, you can use the little slider buttons, and they'll allow you to get it right where you want. So you can even see that the color codes change. The brown, black, brown, green, blue, black, and orange, orange, black. You know, so it's in keeping with the color code. And you can also look at it as a circuit. There, that circuit looks pretty much like what we have on the where is the that pretty much looks like this. So now let's go back to the circuit builder. And there we go. Okay, now you can if we close the switch, why isn't it well, it shows current, but it's not. I'm going to choose this to show the conventional flow. I thought it actually moved, but I don't see it moving. Okay, let's go back to the this view. You can see this is the way the current goes. Now you can see that this is 0.05 amps. Well, what's the current in each of them? Well, if you know a series circuit, they have the current going in each of them. So there it's 0.05 amps. Here is 0.05 amps, and here is 0.05 amps. A very simple circuit. So that's the circuit. Now I'm going to let's reset this, and let's do a parallel. I want to show you the parallel because it's a little trickier. We'll do the battery. We'll do a switch. And we'll do the meter. Let's grab this meter here. Now, I think it'll be easier if we just put a wire here and put a wire here. This isn't really necessary, but I'm just trying to make it look kind of orderly. So we're going to put one resistor, another resistor, and a third resistor. They're in parallel. And we're going to make R1 be 100 ohms. There's 100. We're going to make this one 56. 56, and this one 33. We're keeping the same R1, R2, and R3 in each of these. Now, this is where you can make a mistake. Oops, did the wrong one. Let's put a new wire. Now, the trouble is, if you think, oh, okay, well, now I want to connect it here. You see how that circle, even though it looks like you've got a complete circuit, this red is still this red circle indicates that it hasn't been connected yet. See, it turns black. I'll show you. I'll just do it very quickly and show you that. Let's look like we completed here. And whoop. Okay, I need to cut that and bring this down here. Now, visually, it looks like we've got a connection. But if I close the switch, okay, they are moving. Now, you see these little electrons? They're not moving. Let's do it in conventional flow. Okay, there is even easier to see. See, there are no red arrows in this branch because we really haven't connected it. And that was what I wanted to warn you about. So let's stop this. And let's take this. Let's see if yeah, it's going to move the whole thing. So let's break it here, and let's join it individually there. Let's move this and take another wire and put it here. Oops, we don't want to do that quite yet. What we want to do is we want to take, let's see, we'll do it this way. Do that and extend this and then put another wire here. Now you see all of these are black now. That's good. You want the circles to be black. Now we need to do the same thing. Let's break it here and join it here. Take another one. So you need these individual wires. You can't just make it look like they connect. You actually need a little wire between each of these joints. So let's bring one over here and wrap it around. There. Now we've built a circuit. I didn't do it on the last one, but we used 10 volts, and we used in the lab we used 10 volts, 1,000 ohms, 560, and 33. We could scale everything. Since we're using 156 and 33, we could use a 1 volt, but you won't get much of a reading on your ammeter. So I'm sticking with 10 volts, and you should be able to see that everything scales. So I've got 10 volts. I've got the 100, the 56, and the 33. We close the switch. Now we know that all of these voltages, if we take a little voltmeter, we put this here on the negative end, and this anywhere on the positive, it's going to read 10 volts. Move it over here, it's 10 volts. Move it over here, it's 10 volts. Because on a parallel circuit, the voltage across each of the resistors is the same. Let's dismiss this. Now, but let's put an ammeter in each one, and you're going to get 0.1 amps, 0.18 amps, and 0.3 amps. You see the lowest resistance allows the most current. Then this one's intermediate, 0.18, and this one's 0.10. So in a series circuit, there's one current, but there's multiple voltage drops. You know, I didn't show that. Well, I'm not going to rebuild it because I've already got some built. Let's stop this, and we have the I have one built already, and let me make sure that I've got okay, this one's set for 9 volts, so I'm going to raise it to 10 volts, and we've got 0.33. Oh, wait a minute, all of these are set for I thought I changed those, but we'll do it now. Let's get up there. 100 ohms, 56 ohms, 55, 57, let's go down, 56. And over here, this one's going to be 33. Let's try to get it right at 33. There, 33. Now we've got 50 milliamps, 0.05 amps. And no matter where we put this, you'll see that it's a 0.05 all in every branch. However, this is a nice meter. I wish we had one like this in the lab. We don't. They make what are called current clamps that will read currents without interrupting the circuit. But I know them for pretty high currents. I don't know that they would read anything this low. Now, but let's take a voltmeter. Let's take a voltmeter and measure. Of course, if we measure across the entire branch of the series, you get 10 volts. But what about the first one? Well, let's grab it. Oh, 5.29 volts. 2.96 volts. And measure the last one. 1.75 volts. See, the greater the resistor, the greater the voltage drop. But if you take all of those, they should add up to the 10 volts. Okay, and so just so you know what they look like, I've got, let's dismiss this. We can open this up. And there is the parallel one I made earlier. Here is the series that branches into a parallel branch. And then here is a parallel branch, but this branch is made up of two in series. And all of these were constructed using the little icons over here. So for those of you in my class, you can use these to replicate the circuits and then fill out the I think it's page 7 that has the tables. I want you to calculate your voltages and your currents, and then measure them with this simulator. Okay, and I think that's it. We'll go ahead and stop the share, and let's end the lecture.